A shape melts into the reef. It has no shell, no claws, no teeth built for tearing flesh, and yet it survives. Octopuses do not look like predators. Their bodies are soft, boneless, and fragile. One bite from a larger fish should end them. By every rule of survival, they should not exist. But they do. Octopuses hunt with intelligence instead of strength. They escape without speed. They defend themselves without armor. And they solve problems in ways that seem unsettlingly familiar. They open jars. They plan ambushes. They recognize individual humans. These are not reflexes. They are decisions. Octopuses belong to a lineage that took a radical evolutionary path, one that abandoned protection, rejected size, and invested everything in mind and adaptability. While other animals grew shells, spines, and teeth, what octopuses evolved something far more dangerous: a distributed brain, independent arms, and a body capable of becoming anything or disappearing entirely. Their ancestors once carried heavy shells, drifting passively through ancient seas. Over millions of years, that protection was stripped away. What replaced it was not weakness, but freedom. To understand how octopuses became some of the most intelligent and elusive hunters in the ocean, we must return to a time when survival meant choosing between safety and possibility. This is the story of how losing everything became the greatest advantage of all. Over 500 million years ago, Earth's oceans were crowded with armored life. Early predators were slow but protected. Shells, plates, and spikes dominated the seas. Survival favored defense over speed, and many animals solved danger by building walls around themselves. The ancestors of octopuses were among them. These early cephalopods resembled drifting shells, similar to ancient nautiloids. Their hard exteriors offered protection but limited movement. They floated or crawled slowly, safe but constrained. At first, this worked. But the oceans were changing. Predators became faster. Eyes improved. Active hunters emerged. Heavy shells turned from protection into burden. What once blocked attacks now prevented escape. This created a brutal evolutionary choice: stay armored and slow, or abandon protection and move. One lineage chose freedom. Early octopus ancestors began reducing their shells. Generation by generation, those with lighter bodies could maneuver, hide, and escape more effectively. Eventually, the shell disappeared entirely. This was a dangerous gamble. Without armor, survival demanded something new. Soft bodies required precise control. Vulnerability required awareness. Escape required intelligence. And so evolution shifted its investment. Muscle replaced shell. Camouflage replaced armor. Behavior replaced brute force. These early octopuses were no longer drifting survivors. They became active hunters, capable of squeezing through gaps, changing shape, and exploring complex environments like reefs and rocky seabeds. They were no longer protected. They were unpredictable. And in a changing ocean, well, unpredictability meant survival. Once octopuses abandoned the shell, there was no going back. Survival now depended on speed of response, precision, and control. Evolution answered with a set of innovations unlike anything else in the animal kingdom. The first was a new kind of intelligence. Octopuses evolved large, complex nervous systems, not centralized in a single brain, but distributed throughout the body. More than half of their neurons live in their arms. Each arm can sense, decide, and act independently. This allows octopuses to multitask, explore, and react instantly without waiting for commands. In chaotic environments like coral reefs, this meant constant awareness. While predators focused forward, octopuses sensed the world in every direction at once. Next came perfect camouflage. Octopus skin evolved specialized cells that change color, brightness, and texture in real time. With a single thought, an octopus can vanish against rock, sand, or coral, matching patterns and even imitating movement. This is not passive coloration. It is active deception. Camouflage solved two survival problems at once. Avoid being seen. Approach prey unseen. Then there was escape. Octopuses developed jet propulsion, expelling water to burst away from danger. Combined with their boneless bodies, this allowed them to squeeze through gaps no predator could follow. Even narrow cracks became safe passage. As a final defense, octopuses evolved ink. Released strategically, ink clouds confuse predators, blocking vision, masking scent, and buying precious seconds. Survival does not require winning the fight, only surviving it. Even feeding became strategic. Octopuses evolved beaks strong enough to drill through shells and inject venom, immobilizing prey without prolonged struggle. Energy was conserved, risk was minimized. Each innovation answered a simple question: how to survive without armor, how to hunt without being hunted, how to escape without strength. Together, they transformed a fragile animal into one of the ocean's most adaptable predators. But intelligence comes at a cost, and the ocean would soon demand payment. The history of the oceans is a history of collapse. Mass extinctions reshaped marine life again and again, changing chemistry, temperature, and food webs with brutal speed. For animals built around a single defense, these events were often fatal. Octopuses faced all of them. When oxygen levels dropped and reefs collapsed, armored species struggled. Heavy shells required energy. Large bodies needed stable food chains. Many lineages vanished when conditions shifted too fast. Octopuses survived differently. Their soft bodies required less energy. Their diets were flexible. They could hunt fish, crustaceans, mollusks, whatever remained. When habitats broke apart, octopuses did not migrate far or compete aggressively. They hid in crevices, in rubble, in places predators ignored. During major extinction events, including those that eliminated dominant marine reptiles and reshaped entire ecosystems, octopus ancestors endured by avoiding exposure rather than resisting it. Their short lifespans also mattered. Octopuses reproduce quickly and die young. In unstable worlds, this meant faster turnover and faster adaptation. Traits that worked spread quickly. Traits that failed disappeared just as fast. Even the extinction that ended the age of dinosaurs did not erase them. As large predators vanished, new ecological space opened. Octopuses expanded into reefs, kelp forests, and deep-sea environments, areas where intelligence and flexibility mattered more than size. Extinction did not reward dominance, it rewarded adaptability. Octopuses did not survive by controlling the ocean. They survived by slipping through its cracks. And when the chaos ended, they were still there, ready to evolve again. When the ocean stabilized after repeated extinctions, octopuses did not settle into a single form. They diversified. Freed from shells and rigid body plans, octopuses adapted to nearly every marine environment, from shallow reefs to the deep sea. Evolution rewarded those that could solve specific survival problems with behavior rather than brute force. On coral reefs, octopuses became masters of complexity. Reefs are crowded, three-dimensional worlds filled with predators and hiding places. Reef-dwelling octopuses evolved exceptional camouflage and problem-solving ability. They learned to read their environment, selecting dens, blocking entrances with rocks, and rearranging objects to create shelters. Some even began to use tools. Coconut octopuses were observed carrying shells across open sand, assembling portable shelters when threatened. This behavior reduced exposure and increased survival, clear evidence that intelligence itself had become an adaptive trait. In open sandy environments, octopuses evolved burrowing strategies. They buried themselves beneath the seafloor, leaving only eyes exposed. Here, patience mattered more than speed. Prey passed overhead, unaware, until it was seized from below. The deep sea demanded something else entirely. Deep-sea octopuses evolved slower metabolisms, softer bodies, and reduced pigmentation. In darkness, camouflage gave way to energy conservation. Some species abandoned ink entirely. There was no light to block. Survival favored stillness over escape. Reproduction also specialized. Some octopus species evolved extreme parental investment. Females guard eggs for months, refusing to feed until they die shortly after hatching. This sacrifice ensures offspring survival in environments where chances are slim and mistakes are fatal. Across habitats, octopuses occupied niches that rewarded flexibility over form. They did not become larger. They did not become armored. They became situational. Different environments produced different minds, but all shared the same core strategy: adapt behavior faster than predators can adapt bodies. In the ocean, that made octopuses everywhere and nowhere at once. Octopuses evolved for a world without humans, a world where danger came from teeth and claws, not nets, pollution, and collapsing ecosystems. Today, that world is disappearing. Human activity has transformed the oceans faster than most species can adapt. Reefs bleach. Seafloors are dredged. Noise, light, and chemicals invade environments once defined by subtle signals. For many marine animals, these changes are devastating. Octopuses respond differently. Their short lifespans and flexible behavior allow rapid adjustment. They shift habitats, alter hunting patterns, and exploit new food sources. In some regions, octopus populations have even increased as competitors and predators decline. But this apparent resilience hides fragility. Octopuses rely on complex habitats, reefs, rocky bottoms, kelp forests, for shelter and hunting. When these structures vanish, camouflage and intelligence lose their advantage. A brilliant mind cannot hide on a barren seafloor. They also face direct pressure. Octopuses are increasingly targeted by fisheries and aquaculture. Their intelligence, once an advantage, raises ethical questions in captivity. Stress, confinement, and sensory deprivation affect them profoundly because they evolved to explore, manipulate, and choose. And then there is climate change. Warming waters accelerate metabolism, shortening already brief lifespans. Ocean acidification disrupts prey populations. Rapid environmental shifts compress generations faster than adaptation can keep up. For the first time in their evolutionary history, octopuses face a threat that cannot be escaped by hiding or problem-solving alone. Their survival now depends on whether their environments remain complex enough to reward intelligence. They evolved to adapt quickly. But even intelligence has limits when the rules change too fast. Octopuses are proof that evolution does not follow a single path. While other animals built armor, octopuses abandoned it. While predators grew stronger, octopuses grew smarter. They traded protection for possibility and survived. Their intelligence is not a luxury. It is a survival tool. A distributed mind, adaptable behavior, and bodies that can become anything or nothing allowed octopuses to endure mass extinctions, shifting oceans, and relentless predators. They did not dominate the sea. They outthought it. Now, their future rests in uncertain waters. Octopuses evolved to adapt to change, but not to lose complexity altogether. When reefs vanish and habitats flatten, intelligence loses its advantage. Survival becomes random. The insane evolution of octopuses reminds us that nature does not reward one strategy forever. Strength fails, armor cracks, speed fades. But flexibility, when given space, endures. Octopuses survived by letting go. Whether they continue depends on whether the oceans remain places where adaptation still matters.